So the next idea is how to find the range of a function. Okay. Now we know how to find the domain. So we know, for example, if somebody gives us a function like f of x is equal to, let's say, x plus 1 by x plus 2, or actually let's take something, let's say 2x plus 1 by, let's say, x minus 3. Okay. Now let's say we want to find the domain of this function. The first thing we would do is to see where the denominator becomes 0. So we would say domain equals all real numbers minus the number 3, because otherwise it's a polynomial, and polynomial it's defined for all real numbers. Okay. So you have to only look at where denominator becomes 0. Now, but what is the range? Well, the range is the set of all second elements. Okay. Now we can define f from r minus 3 to r, where your codomain is all real numbers, and we can say it consists of all x comma y such that y is equal to 2x plus 1 by x minus 3. The question is, what numbers will be part of the second element? Let's try. If you put x is equal to 1, you get 2 into 1, 2 plus 1, 3, 3 by minus 2. So for example, 3 by minus 2 is minus 3 by 2. So 1 comma minus 3 by 2 is part of the function. If you put x equals 0, you get 1 by minus 3. So 0 comma minus 1 by 3 is a part of the function. So we know that minus 3 by 2 is part of the range, minus 1 by 3 is part of the range. But what numbers like this are part of the range? Should we actually keep trying every possible number? For example, if you put x is equal to minus 1, you get minus 2 plus 1 is minus 1, minus 1 minus 3 is minus 4, minus 1 by minus 4 is 1 by 4. So you will get minus 1 comma 1 by 4. So you will get a bunch of pairs like these, ordered pairs. But is this enough to find the set of all possible second numbers? Because the first numbers we know is the domain, we can include anything except for 3. You can put root 2, you can put 1 by 5, you can put everything. But on the right hand side, can you say that any number will be attained? Is there something that may not be attained? For example, if we want this value to take this function to take the value, let's say 10, is it possible to find? Well, let's see. Suppose I want 2x plus 1 by x minus 3 is equal to 10. I can solve for this as 10x minus 30. So I get 8x is equal to 31, which means x is equal to 31 by 8. Okay. So it's true that we can indeed get the value 10 by doing what? By taking the x as 31 by 8, because this is 10x minus 30, so you get 31 by 8. But we can't be testing each and every number like this. Okay, how did we know that 31 by 8 will give 10? Because we just asked the question, is 10 possible? Okay, but should we ask this question for every single real number? That's too tedious. So instead what we can do is, we can ask the question, let's say 2x plus 1 by x minus 3 is equal to y, some y. Okay, and let's find what y is allowed or what y is not allowed. So this, if we now solve, is xy minus 3y. Let's try and solve for x in terms of y. So let's take all the x terms to one side. So x into 2, so we can get x into y minus 2, if you take 2x to this side, equals 3y plus 1. So x is simply 3y plus 1 by y minus 2. Actually, if somebody asks the question, can you get this to be 10? Instead of doing this separately, we can just substitute 10 here. 3 into 10, 30, 30 plus 1, 31, 31 by 10 minus 2 is 8, 31 by 8. Now the advantage of having this is if somebody says can you get a 9, I can say 3 into 9, 27 plus 1, 28, 28 by 9 minus 2 is 7, so it's 4. So I can say 4 comma 9 is a part. Is that clear? So the idea of getting this function, solving as y equals this and getting x as a function of y is such that if somebody says is 10 part of the range, is 9 part of the range, is 8 part of the range, we can quickly substitute this and get the pairs. But they are not asking us to find the exact pair. Nobody asked, tell me what is the x that will give me 10. For that you have to solve and get it as 31 by 8. The question when we want to find range is, what values are part of the second set? I don't care what the first number is. Is 10 allowed? Then okay, 10 is part of the range. Is 9 allowed? 9 is part of the range. What numbers are allowed? Well, you look at this and ask, what numbers can be allowed for y? Well, you put any real number for y, this should be fine, except there's one niggling problem where if you put y equals 2, it looks like there is no number for x that will satisfy this because it will become something by 0. Anything other than 2, it looks like you can substitute that and get a value for x. That means you can get this ordered pair. That means the range of f is all real numbers minus 2. Okay. What this function is telling us is that the domain cannot include 3, but anything other than 3 you can substitute for x and calculate. But as you calculate, the answers you get could be minus 1, minus 2, minus 3, 1, 4, 5, 3, 2.5, but it's never going to be 2. That is basically what this is telling us. 2 is not allowed to be part of the images. Okay, every other number is allowed. How do we know every other number is allowed? Because if somebody tells us is 10 allowed, is 9 allowed, we can substitute it and see you get an x. That means that number comma 10 is a pair. That number or some other different number comma 9 would be a pair. Okay, so this is the way to find the range. How would we find the range? If somebody gives us f of x is equal to something, then we treat this as y and then solve for x in terms of y. Okay, this could be any function. It could be, for example, let's say x squared plus 3 by 1 plus x. How do we solve? Now it might be a bit more tricky to solve for x in terms of y, but technically the approach is the same. Try and solve for x in terms of y and then see which y values are allowed or not allowed for you to be able to find x. That is all that is needed to be able to find the range of a function.